All right, now, before you do some more proofs, I'm going to introduce a technique that will help. So this is one of those instances where learning more makes things easier. Okay, I know this might seem counterintuitive because you're being forced to work, but it's true. If you learn this method, conditional proof, that I'm about to teach you, it will make doing a fairly large number of proofs a lot easier. Okay, how does conditional proof work? Well, I'm going to use the example from the book because I'm lazy and unimaginative. So here's the argument. Premise 1, if A, then if B, then C. Premise 2B, conclusion, if A, then C. Now there is a way to do this without using conditional proof. But it's a lot trickier than the way that does use conditional proof. So I'm going to use conditional proof first. Alright. Now the normal way when we see something like this, when we see a proof that we have to do, I say look around and see if there's anything you can do. Can you do modus ponens? Can you do, if there are any syllogisms you can do. Can you do disjunctive syllogism? Can you do hypothetical syllogism? Can you do modus ponens? Those are the things you check for. Because syllogisms combine the information of two lines, which you're going to have to do at some point. Alright, well we look at this and we think, well, if we had A, we could do modus ponens, right? Because A is the antecedent there. And wouldn't that be nice if we could, wouldn't that be nice if we had A? We could do modus ponens. Let's be good to ourselves. Let's give ourselves A. Huh? You say? I didn't know that was an option. Can I just make stuff up? Now, of course, if we're going to be good to ourselves, we still have to say where we got A. We have to write on the line where A comes from. And the answer is, I pulled it out of my... No, that's short for assumption. That's short for assumption. I assumed. And this is one of the rare occasions where assuming does not make an ass out of you or me. We're allowed to do it. Now, why are we allowed to do it? You might think, well, if we're allowed to do that, why don't we just assume the conclusion and then we're done? Well, the answer to that is given by something weird about that line. What is weird about the line as I've written it? It's offset. It's indented. And that's important. It is indented to indicate something. It's indented to indicate that we're in fantasy land. We have left the real world behind. Why have we left the real world behind? Because we're making shit up, right? We didn't have A, we just assumed it. So you can't just write A on the real world because you haven't earned it. The only way you can write something in the real world is if you've proved it, or if you're given it as premises. We haven't. We've just made it up. We've just said, we want it, so we're going to assume it. You're allowed to do that so long as you admit that this isn't the real world. You're just making stuff up. Okay, we're in fantasy land. It's a happy place. Let's see what we can do with our assumption. Why did we want A in the first place? Why did we assume A? So we could do modus ponens. And that will give us if B then C by modus ponens 1, 3. Now we've got if B then C, what else can we do?
C.
We can get C. Somebody else, how did we get C? What's that? What did we use? What rule did we use? Modus ponens, lines 4, 2. So we're just kind of messing around here, except we're done. The proof is done. Wait, what, you say?
Yes.
What? How the hell did that work? Well, the answer is, what we have just done, and notice I wrote that back in the real world. If I wrote this indented, it wouldn't count, it would just be made up. But we're back in the real world, and we have proved, if A, then C. How have we proved it? By something called conditional proof, CP for conditional proof, all the indented lines. So 3, not 3, 5, but 3 through 5. It includes all the indented lines. How does that work? It looks like a cheat. Why do these indented lines, which after all started with me assuming something, just anything I wanted, how does that prove if A then C? What's the answer?
Because you're assuming A is true.
So?
And then you're proving that C is true if A is true.
Exactly. In other words, have we proved that A is true? No. This line is an assumption. We're saying what if. So we say if A is true, let's see what follows logically. Well, this follows logically. So essentially we said if A is true, then C is true. And that's what this says. It says if A, then C. So the way conditional proof works is you assume, if you want to prove a conditional, that's why it's called conditional proof. It only works if you want to prove a conditional. Well, we do want to prove a conditional because our conclusion is a conditional. How do you do it? You assume the antecedent. You say, let's see what happens if A is true, and then what do you try and get on your last indented line? You assume the antecedent on your first indented line, and what's on your last indented line? The consequent. And you've shown that if A was true, then C is true. Now, Fantasyland, there are rules. There are certain things that you can and can't do. It's like feeding the gremlins after midnight. And we'll get into those in a second. But try a couple of proofs using this method. So turn to page 391 and try practice quiz 13.8. So remember, what you do is here's something that is always true. If there's stuff that you can do without assuming, if there's stuff that is immediately obvious that is going to be useful that you can do without assuming, then do it before you assume. You don't have to assume as the first line after your premises. You can wait for a bit before you take the leap into Fantasyland. Maybe you won't need to do it at all. Maybe you can do the proof without assuming at all. And actually, let me just demonstrate that you can do this proof without assuming at all. There we go. Does anyone know how you could do this without assuming? It's actually similar to a trick I showed you when we were doing commutation and association.
Implication.
Well, we don't have to do implication.
So we do computation first and then association.
Well, except you can't do commutation to this. What you do is exportation to line 1, which gives you what?
A and B.
A and B, then C. I'm going to change my pen. Then you do commutation, which will give you what? B and A, because of course you can only do commutation to a conjunction or a disjunction. You can't do it to the conditional. Then what do I do?
Exportation.
Not association. You can't do association with conditional. What do you do?
Exportation.
Exportation again. Exportation line 4, which gives you if B, then if A, then C, and then your last line, which of course will be the conclusion, is what? Modus ponens 5, 2. Yeah. See? So you can prove it without assuming, but it's a bit more tricky, right? That one is a lot harder than just assumption and a couple of modus ponens. So usually you can do proofs without assuming, but it's often harder. So it's good to know conditional proof because it'll make proofs easier. All right, with that in mind, try practice quiz 13.8. It died?
No, I was fixing it.
What's that? If L then M, and if M then L. Now, We've assumed k. What are we trying to get on our last line? Last indented line, that is.
Not.
Not m, because that's the, we assume the antecedent, we try and get the consequent. So we're trying to get not m. Which side of this conjunction, which I can simplify, do I want if I'm going to get not m? Do I want the left side or do I want the right side? The right side. Why do I want the right side? Because what am I going to do next? Modus tollens. What's that? Modus tollens. Modus tollens, what two lines? 6 and 2. So if m then l, denying the consequent, not l, that's going to give me not m. Now what? How many more lines does my proof need? 2. What's number 8? First of all, where is number 8? Back in the real world. So in that case, it's going to be conditional proof 3 through 7. So it's going to be if first line, which was k, then last line, which is not m, right? And then finally, well, obviously finally, so it'll be the conclusion, not k or not m, by implication line 8. Okay? All right, so this is a useful illustration of something important about conditional proof. That doesn't have to be the last line of your proof. In other words, when you come back to the real world, it doesn't have to end there. What I mean is, conditional proof can be used to prove any conditional. Now normally, the conditional will be the conclusion. But in this case, there was no conditional as the conclusion. So what you did was you proved a conditional that you could convert into the conclusion. Maybe you will use conditional proof to prove a conditional that will help you get the conclusion. You know, suppose one of your premises looked like this. I don't know, yeah, like this. Then if you proved if A then B, you could do disjunctive syllogism and get C. You know, imagine that's your conclusion. So you could use a conditional proof to get if A then B. Even though it's not your conclusion, it's just something that will help you get your conclusion, C. So, however, when you do that, when there are more lines of your proof after you've been in fantasy land, there are some rules you have to follow. You don't have to worry about it if your last line is just the line where you say conditional proof. That's fine, you won't get into any trouble. But if that's not the last line, if you're going to go on and do some more stuff here, remember this. You cannot, in any lines back in the real world, refer to lines in fantasy land. So in other words, suppose you were going on here and you're saying, oh, I need K. Oh, there it is. I'll use that K. Why can't you use that K?
He sure like fantasy land.
So what?
So now you're reaching a conclusion that's actually in the real world.
That's right, because you don't in fact have K. That was just dreams. That was imagination. You don't really have K. So you can't use K to prove anything because you don't really have it. It was just a dream. All right? This is fantasy land. So you can't use... Now, of course, you can use lines in the real world you can, in fantasy land, refer to lines in the real world, as we have done here. We referred to line 1 in fantasy land. That's okay. So you can refer to places that are more real than where you are. But you cannot refer to places that are less real than where you are. So you can't refer to places that are to the right of where you are. You can only refer to places to the left. Okay? Yes?
So how did you get if K then not M? Is that from the conditional proof? Is that saying like...
Because we assumed K. So we said, what if K was true? Okay. And then we showed that not M would follow. Okay. So if K is true, then not M is true too. All right. So that's one rule. Don't refer to lines in fantasy, which actually tells you that gives you some strategic advice, because if there's something you can do before you assume, then do it before you assume. Because if you just immediately assume and then do something that you didn't need to assume for, well, you'll have done it in fantasy land and you can't refer to it later if you need it. So if you can do it without assuming, then do it. So if there's like a simplification that you want to get out of the way, do it before you start assuming. It'll just save you time later, because because if you do it here and then you'll want to refer to it later, well, you can't refer to it in there, you'll just have to do it again down here. So basically, if there's stuff you can do before you start assuming, then do it. And then assume. Another couple of points about conditional proof. Look at your homework again. Now, let's look at question 2. For question 2, obviously you could do conditional proof to prove this. Now, it would look like this. You would say on line 4, you would assume P, and then you would try and get, say, on line 99, let's hope it doesn't take you that long, you would get if M then L, and then you go back to the real world and you prove if P, then if M then L, by conditional proof 4 through 99. Boy, that was a long proof. Okay, that would be one way to do it. But notice that this is also a conditional. So here's there's 2 ways you could do this. One thing is, you could notice that what rule of equivalence does something that looks like that make you think of? Don't say association, because association doesn't work with conditionals. Exportation. What is this equivalent to by exportation? P and M then L. So, in other words, what would be a good thing for me to assume to begin with? P and M. Now you might think you're allowed to do that. You're allowed to assume, a complicated thing. You're assuming. You can assume whatever you want, right? You can make up anything you want. So you assume P and M, then say on line 98, see this one was quicker, you get L, then you go back to the real world and you proved if P and M, then L by conditional proof 4 through 98. And then what's the last line of your proof?
Change it back.
By doing exportation. Yeah, so you do exportation to that and you've got if P, then if M, then L. So that would be one way to do it. But there's also another way you can do it that is kind of more adventurous. And that's if you assume P, and then you can do stuff with P. So for example, you can do modus ponens 2, 4. So let's say you do that. And then you indent again. When I said that, it sounded like the Seinfeld episode where he says, then you dipped again. If you don't know that episode, I pity you. Alright, I'm going to assume again. What am I going to assume? M. That's right. So if this was, Oz, this is now Narnia. You were in Oz and then you found a wardrobe and you went through it and now you're in Oz via Narnia. So you're 2 steps away from reality. You have to keep that straight. You have to come out of it step by step. So I assume M again. Then, I go on a few and let's say it's just 35 this time. And I get L somehow. Then I leave Narnia and go back to Oz. So I'm still in Fantasyland, but I'm 1 stage more real than I was before. And I proved if M then L by what? Conditional proof, what line numbers? 6 through 35. And then I can go back to the real world entirely and say what? Conditional proof 4 through 36. What have I proved? If first line, what's on line 4? Then what's on line 36? And that's the conclusion. Now, if you do that, you are allowed to refer to lines in Narnia and the real world. Oh no, this was Oz, wasn't it? You're allowed to refer to lines in Oz and the real world from Narnia. So because Oz is more real than Narnia, you can use lines from there. But you can't, in Narnia, refer to lines from Oz, because that's more fantasy. So again, you can refer to lines to the left of you, but you can't refer to lines from the right of you. All right? Keep your reality straight. Finally, one more trick. Actually, there's a couple more. Suppose I had to prove, as my conclusion, A if and only if B. I had to prove a biconditional. I can use conditional proof to do that. How?
Prove A then B, then prove B then A.
Yes, so let's say on line 4 I indent and I assume A, and on line 20 I've got B. So I go back to the real world on line 21, I've got if A then B. By conditional proof for this assumption 4 through 20. Now what do I do, Josh?
You do the same thing, but
I go back into Fantasyland and I assume B. And then what do I try and get? Yeah, I try and get A. And so I go back to the real world here on line 41 and I proved if B through then A by conditional proof 22 through 40. 2 stages, 2 steps left. What are my 2 steps? Not addition.
Do you switch it back to?
Now, well, notice, I'm trying to get this. So on my last line, I'll have proved this. What must I have used to get this? Biconditional. On line 42. What is this equivalent to by biconditional? If A, then B. And if B, then A. How did I get that? By conjunction of lines 21 and 41. So in other words, I proved a biconditional by getting a conditional going in each direction, and I used a separate conditional proof to get each side. So I used one conditional proof to get if A then B, and another conditional proof to get B then A. You cannot, in this fantasy land, refer to lines in this fantasy land, because they're different. Here, you're assuming A. You're imagining that A is true. That's like imagining, say, imagine that we lost World War II. Imagine that the Allies lost World War II. This one, you're assuming B. That's a different fantasy land. That's like assuming, imagine that there are still dinosaurs. Okay? They're different. Different alternate realities. So you cannot treat this one as if it's the same alternate reality in this one, so you cannot refer to lines in here.